Yo, what's going on, everyone? This is the very first episode of my Let's Code for Saikyo, the cross-platform language learning app. So, there's really nothing to do except just get into it, and I'll explain uh, all of the steps of what I'm going to do along the way. So, let's do it. First thing is that I use CLion as my main programming editor. So, I'm just going to make a new project from CLion, and I guess we'll stick it right here. Call it Psycho Universal, I guess. Stick it in. Cool. And I think if I go full screen, then this should still be on the capture. So that's okay. Okay, so the very first thing is that usually CLion makes a whole bunch of default files and things like this, but it didn't do it this time, so I guess we're going to have to make it ourselves. If you've never seen CLion before, the way CLion works is that it has like a few main primary build systems that it uses to infer the project structure of your C and C++ project, right? Because C and C++ are incomplete when it comes to their compilation and build systems. You need to have an external build system for all of the code to actually come together properly. Otherwise, you're just compiling individual files, and it doesn't become an actual executable. So, CLion's flagship, or not flagship, but it's kind of primary build system that it uses is CMake. So I'm going to use CMake as well. So let's do that. So it says project is not configured. That's obvious. We'll load it. So because the CMake file is empty right now, it doesn't have any of the things that CLion's expecting. So if I remember my CMake syntax properly, every CMake file kind of has to start with a CMake, what is it? Is it minimum version? Minimum required. And then I'm not really sure how much to like explain CMake, but I'll just go through assuming that you have like a minimal knowledge. So CMake minimum required is what tells CMake what version of CMake that you want to use, and I usually go with 3.23 for now. And the reason for that is because it's not too old and it's not too new. I think at the time of recording, CMake, the most current version is CMake 4 point something. I don't remember, but we'll use 3.23. I think 3.23 added a whole bunch of new commands for the way you can use CMake to install your built files into a project or into the user's machine or something. But I don't quite remember. But the next thing you need to have is project, and this is kind of where you name what the project is. So I think you just put the name first. I'm gonna call this Saikyo Universal. Oh, the name Saikyo is a Japanese word. Actually, if you spell it in Japanese, it should be like this for anyone who can read. This might be kind of small actually. So it means the strongest. That's what it means. Um, and the reason why I chose this name is because, to be honest, it sounds cool, and also my name in Japanese starts with Sai, so I thought that was kind of a cute little thing to add in. Um, Actually, you know what? This on smaller screens, it might be hard to see. So let me see if I can just increase the overall size of the whole interface. I think in CLion, if you go to the system settings, you go to accessibility. Accessibility. It is, where is it? Zoom. You can change it with control option equals. So control option. Yeah, there we go. This might be easier to see if you're on a mobile screen watching this. So let's choose a good font size. Maybe font size 18? 20? We'll do 20 for now. Hopefully this looks okay on the capture, but we'll see. So yeah, we have the project, Saikyo Universal, and then also you can tell it what languages you're going to use as well as a keyword to this function, macro, whatever this is, in CMake. So we're obviously going to be using C. We'll probably use CXX. I usually put these two together because sometimes, well, depending on what you add here, you can pass different files to the compilers and it will just work magically. Now, as you can kind of tell, I'm running macOS right now. You can tell from the button controls and stuff. So because we're running macOS, we'll also need to add one more thing. So what I'm going to do is I'm going to put an if here. I'm going to put an if, and I'm going to say if Apple. Now I think Apple includes both iOS and OS X. I don't remember if there's an OS X variable, but we'll just say Apple for now, since we will want this for iOS eventually as well. You can while you can put languages here in the top of CMake, you can also use a command called enable language. And the language that we need to enable for Apple's platforms is Objective-C. But actually, we're going to use Objective-C++ instead. So Objective-C is kind of the object-oriented version of C that Apple used in their original whatever it was. When Steve Jobs rejoined Apple in 1997 or whatever, he took his new OS, Next OS, ported it over to Apple, and that's what became OS X. But Next OS originally used Objective-C as its implementation language. But over the years, people want to interface with C++ as well, so that way you have the kind of compile time validated object orientation. Objective-C++ is a lot more like Java in that Objective-C as well. It's a lot more like Java in that you have a runtime that does all the object-oriented stuff, whereas with C++, the object classes and all that stuff is more statically compiled into the language. So we want to have both. We want to have both, and we also want to be able to call our C++ code from the Objective-C code, so that's why we have to enable Objective-C XX like this. And then the next thing that we'll have to do first is we're probably going to have to create a file. So I'm going to create a file. We'll call this appkit. If it's Objective-C, it would be like .m, but if it's Objective-C++, it's .mm, because I guess M means module and MM is like CC, follows that naming convention. So we'll add that to the thing. As you can see, CLion picks up that this is an Objective-C file. Also, I don't like how CLion by default puts your build files inside of this kind of templated folder name, so I'm going to change that as well. The way you do that is on a Mac, I just type command comma. On Windows and Linux, I think it's Control, or maybe it's Alt Shift S or something like that. Control Shift S, maybe. But you go down to build, execution, deployment, CMake, and this is where you can see all of the configuration stuff that CLion passes to CMake. So our default is that this is the debug configuration. So we'll be using Ninja as the generator. Again, not sure how much I should talk about CMake, but basically CMake is like a meta build system. It generates the build system that an actual build system would use. So you write the CMake. CMake will then create files for the Ninja build system, which is fast parallel build system that I think is pretty common these days. And then you actually use Ninja to build the code. But the option that I care the most about is build directory here. So I usually say like build/debug. That's good enough for now. And so now this folder will go away, and we have our CMake files inside of it. Here's the main like Ninja build file that you would use Ninja to use. You would invoke Ninja with this file, and then it would go ahead and it would build all of the code. And right now, there is no code because I haven't added anything. So to add to the CMake build system with the program to compile, then you need to say add executable like this. So we'll do add executable. You give the name of the executable, the name of the target that CMake uses. So we'll just call this appkit. And then you give the source files. And we only have one source file, so it's pretty easy. It's just appkit.mm. So if I reload the CMake project, because CLion doesn't do it automatically, now you can see that CLion's kind of woken up. You can see that we're going to be running in the debug profile. We have one executable. call Appkit. If I compile this now, there's nothing, because you need to have, for an executable, you need to at least have a main function, and we don't even have a main function. So that's what this error is about. So we'll actually need one more thing as well from this, which is if we are running on Apple, we'll also need to include a set of libraries, and we're only going to use the operating system libraries. We'll write the rest of the code ourselves, since this is one half entertainment, one half education, and two halves fun. But okay. So I think what I'll do is I'll just add a libs. So we'll create an empty variable called libs, and then what I'll do is I'll append, I think it's list append, isn't it? To libs. Let's see if this works. I haven't actually done it this way. I usually can include it manually, but we're going to add to the link line the framework on macOS to add. So I think it's spelled like this. And then what we'll do is we'll do a target add, nope, it's target link libraries, like this. So add executable creates the executable target. If you want to tell on the command line, you would usually use, like, say, CLion or GCC, like a -L flag to include libraries to link with. With CMake, with target link libraries, you can do the same thing. So the first thing is you add the name of the target, which is Appkit. You can either add a public or private. As you can see, public means that your libraries will be, that you link with, will be linked with other things that link with you, other targets. This is an executable, so this is like the last rung of a dependency chain. So we'll just make it private for now. And we'll see if we can just do this. I'm not sure if this will work, but let's see, actually. Okay, doesn't seem to be an issue. Seems to be okay. Can I build? Obviously still not. But it looks like maybe this will work. So we'll see. So we'll just make a little dummy. Also, there's one more thing I forgot. So C++ has a lot of different versions, right? You got C++ 98, C++ 3, 11, 14, 17, 20, 23, and I think 26 is almost available. It will be available next year. But depending on the C++ version, right, you have different syntaxes and features that you can use. So what I like to use as my base standard is C++ 20. It's got probably the nicest feature set of C++, modern C++ that I've seen. So the way that you can tell CMake to use C++ 20 for its compilation is you have to set the CMake CXX standard variable, and you just set it to the number. So I think 98 is C++ 98, 03 is 03, 11 is C++ 11, etc., etc. So we're going to set this to 20. And if I do that, CMake is happy, then I can start using order as my features. Actually, to see, we can see if this link step worked correctly, I should be able to include Appkit, and I can. So I think probably this worked just fine. And CLion now is going to freeze a little bit because Appkit, it's a really big header. It's a header that includes other headers, if I'm not mistaken. Yeah, it's one of those umbrella headers that includes everything. The NS means next step. So you can see the lineage from next step to OSX. And Objective-C uses import instead of include. I'm not sure actually what the semantic differences are. I think they're just trying to be cute to kind of match Java and other object-oriented languages from the 90s. But yeah, we'll use #include because that's what you use in C++. And now we should be able to say order main returns an int, and we can just return 0 like this. And we'll see what happens here. So will this build? It will build. Will it run? it will run kind of slowly. Very good, very good. Okay, cool. So we've got our build set up. So what's the very first thing that we should do next? Let's see. Let's try if we can see. Let's see if we can open a window. As the very first thing that we do. So, to open a, actually, there's one more thing I wanted to do. Although it looks like CLion's already picked up, so I usually like to use a clang tidy file for the clang tidy and also clang format. So I'm looking for clang format. There it is. Yes. Yes, I usually use clang format for formatting and linting, and then clang tidy file for checks. If you don't know what these are, basically the LLVM project and Clang. Clang is the default compiler on macOS, Apple Clang, which is not the same as regular Clang, unfortunately. But as support tools, LLVM also comes with a linter and a style checker formatter, and that's what Clang Tidy is, the linter, so it has a whole bunch of checks that it goes through, and it will create problems in the code. I think, for example, if I do, for example, let's see, if I have like a float array, we'll just do whatever, and then I add in a double, will this, no, double q equals 2, it should create warnings like you're going to be, yeah, like kind of like this, q is a double, and then yes, like these kinds of things. So with Clang Tidy is what's picking this up. Essentially, what's happening is that a double should be 8 bytes, and a float should be 4 bytes. So by initializing a float array with a double, you're going to be cutting off half of the precision, well, not half the precision, but you're narrowing the double to fit it inside of a float, and that can create precision issues. And in C++, as of 11, whenever you use these curly braces for initialization, it will, in C++, they call it universal initialization. Basically, it won't do narrowing conversions. It won't just convert Q into a double silently. It will give you an error. And that's what's happening here. And CLion picks it up. This isn't actually a compile error, I don't think. Okay, with Clang Tidy, this is making it a compile error. Actually, probably not. Probably the fact that this is a C++ 20 compiler is the reason this is becoming an error. So you can't do that. However, if I come to here and then I do g of 0, g of 0 equals q, this will probably be okay, but this is kind of what I was more expecting. Here, Clang Tidy picks up that this is now a narrowing conversion as well. So you can also turn these kinds of warnings into errors from the CMake, the compiler flags that you can set in CMake. I'm going to do that a little later, not right now. But the point is that having these extra files here is really important for development. So you should have them. And I'm sure if you work in a big project anyway, you're going to have a file guide, a style guide, or these files distributed with your code base anyway. So it doesn't really matter whether or not you get this right now, because you will almost certainly come across these in your day-to-day life. Okay, cool. So now opening a window in any of these OS frameworks is not necessarily difficult. There's just like intricate steps, and I want to see if I can remember how to do this without looking at the documentation. So the first thing is that with AppKit, your entire program is considered to be like a graphical application. So the first thing that you need to do is, I guess we'll call this AppKit app. Or actually, no, what we'll call this NS app. And the first thing you need to do, I think, is you have, is it initialize? Initialize, maybe. Perhaps not. That boy. No, this will be the wrong thing. So what I'm getting at is that there is a there is a global variable, which you might have seen in the IntelliSense that just popped up, called NSApp, which is this thing. And this is a pointer. Yes, like this. So, okay, two things with the syntax. One, the way that you call a method in the way that you would normally do it in C++, right, is you would use this kind of dot syntax, right? But Objective-C isn't like that. With Objective-C, the idea is that you're not calling a method, you're sending messages to an object. And that's how you do that. This is the syntax for that. So there is an object, in this case, NSApplication is a class, and it has a class, a static method, a class method, whatever, called initialize. And what this does is it creates it doesn't create, it initializes this global variable called NSApp. Actually, this might be a great time to bring up the documentation for this, so you can also see what this looks like. So Apple has their documentation for AppKit at this URL, and this is the main touch point for seeing where and what all of these methods that we'll be going through in the future look like. So there's a little search box down here. So if I just type in NSApplication, you can see this is the main thing. And yeah, there's this shared app object. And actually, it might be shared application. I think actually accessing shared application at the start also will initialize it. Yeah, so this makes a connection to the Windows server, completes other initialization. And we invoke this method as one of the first statements in main. Right. That's how you do it. So probably this initialize method will be called internally, but what we need to do, which is what I was thinking of before, is that you use NSApplication and you then do shared application like this. And what this will do is we're sending the shared application message to NSApplication. It internally is going to go through and do the initialization, and it will return to us the application thing, the global variable. Now, this still won't actually create a window. This will exit properly, but this puts us in the great position that now we can go ahead and open a window if we want to. And the way that we do that, I always forget because it's large. But the first thing that we'll do is we'll create the size of the window. So we'll call this window dimensions, maybe win dimensions, like this. And inside of AppKit, they provide like, what would you say, value types. So there's like an NS, I think it's NS, what is it? Rect. It's NS Rect. So there's an NSRect class, or it's a struct actually, and what it is it contains, it's actually a type def for core graphics rect, but that's not really important. The point is that inside of it you have a point and a size. So right, you have multiple ways you can define a rectangle, and AppKit decides that it wants to use the origin and extent format to create the size. So we'll do that. So we'll put the window at, I don't know, 200, 200. This is just off the top of my head. There's really no reason behind this. And we'll make the window size initially 400. So that should put the window like around here, I think. And then the next thing is that we can go ahead and try to create the window like this. So there's, again, if we go back to the documentation, there is a class called NSWindow. There it is. And it's just exactly what it is. It's a window. But you use it to place, like it says, place views in provided area, and to get from the event run loop events, input, etc., and then to forward those to the various views. Now, we'll talk about this going forward, but the way that you create one of these, I believe, is that we'll use this one. We'll use init with content rect. So this is how Objective-C works. So the name of the function is init with content rect, and then the rest of these technically this is also a parameter, but it's also the name. But these are arguments to the function. So in it with content rect is the rectangle we just made. It's the size and everything. Style mask is just a bit field. And it tells you what kind of window you want. For example, do you want a borderless? That will be useful if you're making a game. Do you want a titled? So that would be like this. If this is titled, there will be a title right here in the middle. If you want a closable, it will put one of these buttons. Miniaturizable puts this button. Resizable means that you can resize the window, etc., etc. It's kind of straightforward. Defer is whether or not we want this to be hidden or to create it directly after the window is created. We want this to not be deferred, I believe. And then I think for screen, actually no, we'll use this one because we don't have more than, right now I don't have more than one monitor. And you would pass which screen you want this window to appear on. For us, we'll just do it here. So we drop the screen argument and we just need the style mask, the backing star type, which is what I've missed. We want this to be, I'm pretty sure you can only have this be double buffered now. Yeah, buffered. Because all graphics devices basically double buffer or triple buffer or even quadruple buffer frames for displaying onto the window. So that's easy. And then defer is, do we want the window to be created now or do we want it to be created once it's moved on screen? This is going to be the main window, so we'll have this on screen straight away. So we'll do that. So what we'll do is we'll do ns window. Now there's one more kind of little trick with, yes, there's one more little trick with Objective-C, which is that you don't just construct it, you also need to allocate on the heap because everything is a pointer because it's object-oriented, unfortunately, for us. So the way that you do that is basically everything begins with an alloc. And what this does is it's essentially new from, say, Java or C++. And after you've got the pointer, at that point you construct it. And that's where we'll use this one. So we'll pass the dimensions, it's win dimensions, and I think the way that we do this is we can do it like this. So style mask, I believe that's what it was called. Yes. And then style mask is, we'll create style mask up here actually. So this is an auto win style, we'll call this. So while this is an integer, I want to see the thing. So we want this to be closable. We want this to be miniaturizable. What we'll do is put this down here. Like this. And what else do we want? Resizable, yes. And I also want this to be titleable. Probably we want that. Yes. And we'll do title. Sweet. So our style mask is now win style. I think the next argument was backing. So the backing will be easy. This will be win ns backing store buffered. And then finally defer is the only thing missing. So defer, we want this to be, so since Objective-C was kind of created before newer versions of C, they have a type called _bool, like this. C++ has the bool type. So we have actually like true and false, right? But in Objective-C, they have kind of true and false hash defined to be yes and no. I think these are basically the same as true and false, Objective-C, no. So these are going to be built-ins. This will almost certainly be 0, and this will almost certainly be 1. So I guess we'll just use their hash defines. There's really no problem with not using it. And let's see. If I do this, what will happen? Nothing happened because we didn't stop the program. So we'll just create not with, this is a while. Actually, this may still not work, even if I spin for infinitely in a while loop, because what we need to do is we need to, set the window to be front and center. So the next thing that we would need to do is, I think you have to say make main window and then make key and order front, and then it's going to be null. Actually, I believe in C++, in Objective-C, they have null also defined to be nil, so we'll do that. Now, the main window is, say, the primary window for the application, right? Because you can have modules and dialogues and things like this. Now, make key and order front means that this window will become the window that is, whenever there's keyboard input or mouse input, this window will get it first. And also, it will be ordered to be the uppermost window, so that way you can see it on top of other windows, I think. But let's see if that fixes it. Also, we're still not... The order that you do this also matters, which is why this is always annoying. Can become main window is false. I think if we do this, it will actually fix up, maybe. And again, we're still not spinning. Okay, so we're still not seeing a window, and the reason for that is because also we need to service the run loop for the window. We need to kind of grab off of the event loop events, so that way the window will eventually pop up. Because it won't actually do that, I don't think. So what we'll do is we'll do that next time. So today we covered kind of setting up a basic CMake file and also sort of an introduction to making a window. So we're almost there. Next episode, we'll go ahead and we'll get this window showing on the screen, and it'll be good. So thank you so much for watching, and I will see you next time. So have a good one. Onward and upward.